In this tutorial, I'm going to explain how to use the Fiji software to generate the three-dimensional TIFF images that are needed by PuMA. The Fiji software is a pretty powerful, robust image processing software that's used in tomography applications and medical applications. In order to download Fiji, type in Fiji and then image. If you don't type in that, it'll just come up with Fiji, the country. And you can click download, and in this case, Linux 64-bit. It might take a few minutes to download it. It's a somewhat large file. The code is written in Java. It's an open source project that has a number of contributors. And being written in Java, it has the advantage that it runs pre-compiled right out of the box. There's really no installation process at all, which makes it a very useful tool. So once it's downloaded, open up the download location, move the zip file to wherever you want it, in this case, just the desktop, and then extract it. Once you open up the folder, you'll see that there's an ImageJ Linux 64 option. If you click on that, the software will be launched. Now in this tutorial, I'm going to show how to take the three probably most common file types that are not 8-bit or 16-bit TIFF images, and how to convert that into an 8-bit or 16-bit TIFF image using Fiji. Sometimes the data from tomography scanners will come as a 32-bit TIFF image. If that's the case, simply drag it into Fiji, but it can be imported into Fiji by saying File, Open, or Import, but in this case you can also just drag the file in. Once it's loaded, then you'll see the data here on the top. It's 512 slices. You can scroll through it, and you can see that it's a 32-bit TIFF image. In this case, to be used in PuMA, it needs to be either an 8-bit or 16-bit, and it's important that it's 8-bit grayscale, not 8-bit color. So it needs to be 8-bit or 16-bit. Typically, 8-bit works a little bit better just with the QT image viewer, so I recommend that it's converted to 8-bit. Then once that's done, you can say File, Save as TIFF, choose the appropriate file name, and save the image. This should then now be able to be imported in PuMA, which we can test. And you can see, yes, in fact, it is. If, for example, you tried to import this, you should get an error saying that the TIFF must be 8-bit or 16-bit. Another common file type is the raw file type. In order to import the raw file type, it can be just dragged right into Fiji as well, and you have to import, you have to tell it the width, height of each image, and the number of images. So in this case, it is 512 cubed. You have to know that going into it. And as you can see, it was able to import the 512 cubed image. It's already stored as an 8-bit. You can say image type, make sure it's 8-bit, and say File, Save as TIFF, and save it as the 3D TIFF. Another common way that tomography files are stored is in an image stack, where each of these images represents one slice in the 3D image. In order to then convert this to a single three-dimensional TIFF, using Fiji, say File, Import, Image Sequence, and click on the first image. It should recognize that there are 512 images. You can set the increment, which in this case we want to say is 1, and say OK. We can see that it is in fact already stored as 8-bit, but if that needed to be adjusted, again, we can go image type 8-bit. One other thing in Fiji that I should mention is that it's very powerful for image filtering. Eventually, some image filtering capabilities will be included in the PuMA software, but for now, I recommend that users use Fiji if they need to do any filtering. In this case, obviously, there's no filtering required because this is actually an artificial material created by PuMA. But in the case of a real tomography sample that requires filtering, you can use process, filters, and then the number of filters. The most common one that I use is the median 3D filter, which lets you choose a radius and X, Y, and Z in order to apply the median filter. And then also probably the most powerful filtering is the, you go to plugins, process, and bilateral filter. And I won't go too much into the theory of a bilateral filter here, but basically you specify two three-dimensional radiuses. Well, one three-dimensional spatial radius, and then a range radius, meaning that if it drops below a certain amount in terms of a difference, so if the grayscale drop is above a certain amount, it won't apply the median filter at that location. So it's an edge-preserving filter. But in this case, no filtering is needed. That pretty much covers how to import either a raw, a non-8-bit TIFF, or a TIFF stack into Fiji, and then save it in such a way that it can be used in PuMA.